Good morning and welcome to the first lesson in our new unit on polynomials, which is an extension of what we've been studying all year. So we're going to talk today about what end behavior of polynomials is, and I'm sorry that we have to start off with a lot of vocabulary to make sure that we are on the same page with what we're talking about, how it's defined, and also how it connects to what we've already studied. So I know vocabulary can be dry, but it's really, really important that we're understanding the words that we're using and the directions that we're given so that we can communicate fluently in math. So the first set of vocabulary words that we're going to talk about are words that we've actually been using for a while, even though I haven't necessarily formally defined them. So I think you'll find this to be pretty intuitive. If you look down the list here, you can see that we have the words monomial, binomial, trinomial, and then polynomial or polynomials, just kind of as a broader heading. If you think about how words are put together, we have some prefixes here that can help you decipher what the words mean. For example, most of you know that the prefix mono means one. The prefix bi means two. Tri means three, as in like a triangle has three sides. And then poly usually refers to many. And all of these are followed by this nomial, which often means like numbers or related to numbers and so forth. So we have like 1, 2, 3, and many of something. So what is that something? We'll start with monomial. A monomial has simply one term. So we're like wondering, okay, one, but one of what? One term. Now, it's important to know what the word term means. And we've used this before because we talk about combining like terms. And I know I've defined this before, but it's good to go over it again. One term means that you have one expression with no plus or minus sign. So no plus or minus sign in your expression. So for example, so we'll look at like some examples of monomials. Let's see. The number 3 is a monomial. Kind of boring. So you've actually been dealing with monomials ever since you knew anything about numbers. Just nobody would use that word to describe them. So 3 is a monomial. The variable x is a monomial. It consists of this one term, and you've been dealing with variables for many years at this point. Now, 2x is also considered a monomial, because there's no plus or minus sign. So this is 2 times x, and they are like joined together to form this one expression. You could have multiple variables in there. So you could have something like 4xy. That would also be considered a monomial because there's no plus or minus sign. And the last example, if you're looking at the notes, is 3x squared y to the 4th. So you can have multiple factors in there. You can have a negative number. You could also have fractions, decimals, any kind of real number. You can even have imaginary numbers in there. They would still be considered monomials. So we have like a negative 3, and then you could have like x times x or x squared and y to the 4th. As long as you don't see a plus or a minus, you are dealing with a monomial. So once we have a handle on monomials, then it becomes pretty easy to define binomial and trinomial. A binomial has 2 terms, and we've used that a lot when we've been dealing with quadratics. So for example, x plus 7 is a binomial, and we've done a lot of like multiplying binomials together. So you take x plus 7, which is a binomial, and multiply that by, say, x minus 3, which is another binomial. When you multiply binomials, you often, though not always, get a trinomial, which will not shock you, has 3 terms. And we've done a lot with trinomials. So like x squared plus 2x minus 15 is a trinomial. And you can count the 3 terms. So you have x squared as a term, 2x as a term, and negative 15 is a term in that. And so 3 terms gives you like what's called a trinomial. Now, polynomial. the actual definition for polynomial is kind of scary. It has a lot to do with like what form the exponents are in. It's the kind of definition that would probably freak a lot of students out. And so I avoid giving you the formal definition for a polynomial because the concept is actually fairly simple and it's a little bit easier or less intimidating to define polynomial by using a lot of examples and maybe telling you what is disqualified from being a polynomial. So polynomial simply means it can have many terms. So can have many terms, as many as you would like. But notice how I phrase that. I phrase that as it can have many terms, but it could also have just one. And so we'll put that in green. But could have just one. And so the idea with the expression or the word polynomial is that it does encompass the other words there. So a monomial is considered a polynomial, even though there's only one. Because of course many, like the word many is vague. How many do you have many? And so mathematically the way we use that is like really polynomial is an umbrella term that encompasses monomial, binomial, trinomial, and anything bigger or longer. So I have several examples of polynomials here just so we can, so we can get a handle on what polynomials are. So for example, 2x plus 3 is an example of a binomial. I'm looking at my notes there. That is linear. That is a binomial. It's an example of a polynomial. If you were to picture this, and I'll kind of get rid of this, like y equals 2x plus 3, I hope would recognize that as being a line because it takes the form y equals mx plus b with a slope of 2 and a y-intercept of 3. So when we've been studying lines, we've been studying polynomials. I'll go ahead and get rid of that though. Let's see, x squared minus 3x plus 4. That is a quadratic and that is a trinomial. It's a quadratic trinomial. So we're throwing all kinds of vocabulary out there with this. And it has like the 3 terms. That's considered a polynomial. Now we can get into some like really weird stuff that we actually don't do a whole lot with in Algebra 2, but you could have something like 2xy minus 3x squared. Now that is what's called a binomial in 2 variables because you've got the x and the y in it and they're multiplied together so they're part of the same term. You can't, So this is considered a binomial in 2 variables and it's really beyond the scope of Algebra 2. When you get to some of your higher level calculus is when you start dealing with like functions that are in 2 variables. So, but a lot of what you learn in 1 variable, like, cause you know that math is consistent. And so what you learn in 1 variable does actually extend to more than 1 variable fairly simply once you learn the 1 variable really well. But I don't want anybody freaking out over that because we're not going to do stuff with more than 1 variable in Algebra 2. So I did mention a little bit earlier that the actual definition for a polynomial is kind of complicated and it involves some notation with subscripts that you probably would not appreciate too much. So what I'm going to do to try to define polynomial is give you kind of the main restriction on it. And what you'll see here is the main restriction has to do with the exponent. So the exponent, all the exponents in a polynomial must be positive integers. So your positive integers would be like 1, 2, 3, 4, and so forth. Now, technically, you can also have a 0 there, although we usually don't write an exponent of 0 because there's it means the term that goes with it is equal to 1, and so we just don't bother to write it. We usually also don't write the exponent of 1 because it's implied. So you should have exponents that are positive integers. So what I've got here is like a place for a counter example. So what are some things that are not polynomials? If you see an exponent of -2 or negative anything on a variable, it could be on the constant, but on the variable, that would not be considered a polynomial. And we haven't really gotten into what negative exponents are. We will get into what negative exponents are, but they're essentially fractions. So you can't have any negative exponents. You also could not see anything like this, where you saw an exponent that was a fraction. So that is supposed to say 4x to the 1/2. You also need to be careful of anything that would mess with the variable. Now, really, what you can't like mess, when I talk about mess with the variable, I'm not using very precise mathematical language there, but a negative exponent actually means the variable is in the denominator. Rational exponent, or exponent that's a fraction, actually means that the variable is under some kind of radical, like a square root, for example. You want to avoid anything like that. So your polynomials should always take the form, I'm going to write down here at the bottom of the screen so you know where to look, would take the form of some kind of number. Okay, so I'll just use like a 2 times x, and then the exponent on that x is going to be some kind of positive integer. If you see other weird stuff, like you see 2 over x instead of 2 times x, that's going to be a problem. That's not a polynomial. If you see the x and the x is under a square root or a cube root, that is not a polynomial. And if you see something really weird like log of x, which we haven't studied at all at this point, not a polynomial. So what you're looking for in determining whether something's a polynomial is you're looking for a number. Now that number could be a fraction or a decimal or a square root. Okay, it usually won't be, but it could be. The number can be anything you want. Times x, and then the exponent would have to be an integer, or like the positive integer. Now, what I have down here next is just, you have polynomial expression, polynomial equation, polynomial function. I just want to make sure that we take some time and differentiate between the two. So a polynomial expression, it has no equal sign to it. Okay, so there's no equal in it. So for example, you might see something like the x squared minus 2x plus, I don't know, plus 4. Okay, that would be a polynomial expression where there's no equal. One of the major issues on the quadratic equations test that you guys took is when you were dealing with expressions that had no equal sign, a lot of you were putting equal signs in. So you were changing an expression into what's called an equation. So a polynomial equation has an equal sign. So that would be something like this: x squared minus 2x plus 4 equals 0. It either doesn't have the equal sign or it does have an equal sign in it. If it does have an equal sign, then you might be asked to solve it. You can't solve an expression, okay? You can factor an expression, you can simplify an expression, you can rewrite an expression in different ways, but you can't solve it. To solve something, you have to have an equal sign. You have to know what the expression is equal to in order to figure out what x is equal to. So please do not put equal signs into problems that don't have equal signs. On the flip side of that, if there is an equal sign, you can't drop it out and ignore it and pretend that it doesn't have any impact on the problem. So on the test for quadratic equations, a lot of you looked at the equation and then you just factored it and you left it, and the equal sign was gone. You just didn't copy it over to the next line. So it does make a difference whether something has an equal sign or doesn't have an equal sign, and you can do different things with the problem based off of whether it does or doesn't. Now, this last one, I actually don't necessarily differentiate a lot between an equation and a function, but there is a difference. A function would often have an f of x or y equals in it. So for example, you would have y equals x squared minus 2x plus 4. And these you would often graph. Okay, so you would be asked to graph a function and solve an equation. So you might say, well, that's got an equal sign. That's an equation too. Yes, you're right, which is why I usually don't make a big deal about the difference between the two, but they can make a difference in terms of what you're asked to do. So, and your book and other resources will often have a distinguishing they'll distinguish between the two. So yes, this has an equal sign, but it's usually called a function, and you would be asked to graph it or find the vertex or find the x-intercepts. If it's equal to a number, then you'd probably be asked to solve it and figure out what the value of x is. And if it doesn't have an equal sign at all, it's just an expression. So that finally leads us into two main vocabulary words that are really, really important features of polynomials. The first really, really important vocabulary word is degree, the degree of a polynomial. Now, there's actually a more complicated definition of this because remember, polynomials can come in more than one variable. But because we're not dealing with polynomials in more than one variable, we're going to keep the definition simple. And for our purposes, the degree of a polynomial is simply the largest exponent on the variable. I don't know exactly what happened to my iPad there. That word right there is the word variable, and it really did not come out very good. Now, usually that's going to be the first term in the polynomial, but not always. So we don't define degree as the exponent on the first term because we can rewrite the order of the terms any way that we want. The degree is simply defined as the largest exponent. So as an example, if you were to see 3x to the fourth plus 2x to the third minus 4x squared plus x to the first minus 3, and you were asked, what's the degree? What you would do is you would look at all the exponents. Now, usually you would not write the x to the first power. You would just say x. And really, there's an x to the 0 power out there because x to the 0 is equal to 1, and negative 3 times 1 is just negative 3. So we usually don't write that either. So you would go through and you would look at all of the exponents, and then you would choose the highest one. So we would say this is degree 4. Now, usually, if the polynomial is in what's called standard form, which means it's in descending order of exponents, then the degree is going to be the exponent on the far left. It'll be the first one you see. But that's not the definition. So for instance, if you were to see something like this, if you were to see negative 2x squared plus 5x to the fourth plus 3x to the first minus 1, and you go through and look at your exponents, this would also be degree 4, even though the 5x to the fourth is in the middle of the polynomial. Now, I mentioned a second ago something called standard form of a polynomial. And we've talked about standard form for quadratics. And if you think back to your quadratics, because remember quadratics are polynomials. Standard form for a quadratic is ax squared plus bx plus c. So you start with the highest exponent and then you work your way down. That is essentially what standard form of a polynomial is. So standard form of a polynomial just means the exponents go in decreasing order. So you start with the highest exponent and then work your way down. So let's take a look at this example from the previous slide, which is over there, this one right here, and rewrite this in standard form. So if I rewrite it in standard form, I'm going to look for the highest exponent, which is the 5x to the fourth, and I'm going to move that over to the far left. Then I have the next highest exponent is negative 2x squared. And then the next highest exponent is 3x. And I'm not going to bother writing to the first because that's silly. And then you put the constant. That actually goes with an x to the 0. That's at the end. And that's put in standard form. Now, I want you to notice something. I want you to notice that we're jumping over one of the exponents. So we start off with x to the fourth, and then we're kind of jumping down to x to the third, x squared, and we have left out x to the third. So if we were going to count down perfectly, we would go 4, 3, 2, 1, 0, and the x to the third is missing. So I'm going to do something here. I'm going to put in what I call the missing term, which is going to be 0x to the third. And we'll be really clear about this. This is standard form. You do not have to put in the missing piece in order for it to be in standard form. But I want to really draw your attention to the fact that there is an x to the third that you could put in. Now we have 0 of them, so that's why it's 0x to the third. 0 times x to the third is 0, which would cause it to cancel out. But I want you to be aware that it's there. Trust me in that comes in very important later on, that you're aware that you could do that. So we're going to look at a couple of practice problems. I'll put them on the next slide along with the directions for what I want you to do. So here are the directions. I want you to look at these expressions, identify the degree, write them in standard form. Sorry that N is capitalized. Write them in standard form, and then if there are any what we would call missing, I know I've got it in quotation marks there, missing terms, I want you to include those missing terms in your rewrite. That's not essential for standard form, but it is essential for a division of polynomials, which is coming up. So first one is -3x to the fifth plus 2x to the third plus x squared minus 3. Second one is 4x plus 3x to the third plus 2x squared plus 1. And the third one is 2.3, changing that up, x squared minus 3x to the third plus 5. So I'm going to pause the video here. I want you to identify the degree, write it in standard form, and if there are any, quote, missing terms, include those. And here are the answers. So for the first one, you should have written that the degree was 5. Now that one is already in standard form. So if you look at the exponents in that, they go 5, 3, 2, and then the constant. And so they are in descending order. They're already in standard form. But I asked you to also include any missing terms. So in between the 5 and the 3, you should have 0x to the fourth. And in between the squared and the constant, you should have what's called the x term or the linear term, which would be 0x. And so you should have included those two terms. Second one is degree 3. And that one is not missing any terms, but they are out of order because the exponents go 1, 3, 2, and then the exponent of 0. So you do need to reshuffle the order so that the x to the third is out front, and then 2, and then 1, and then 0. And then the last one is also degree 3, and that one is out of order and also missing a term. So you would want to put the negative 3x squared, 3x to the third out front. Make sure you bring the negative with it. That was a negative 3. Then you have 2.3x squared. You're missing that linear term, which is the 0x, and then you should have plus 5. Every single person taking Algebra 2 is capable of identifying the degree of a polynomial because it means looking at a bunch of numbers and picking the biggest one. That's all it is. Where people get this wrong is they don't learn the vocabulary, so they don't know what they're looking for, and I get all kinds of interesting answers. All right, now we have, it's going to be a long lesson. We do have to cover one more other vocabulary word, and it'll be pretty simple, so let's get on that. The vocabulary word here, or words, is leading coefficient. So if we break this down, hopefully it'll be intuitive. Leading means to go out front. Okay, if you think about in elementary school, you had like a line leader. The line leader was the person in the front, leading the line. Everybody else follows. Coefficient is simply the number in front of the variable. So leading coefficient is the number in front of the first variable. To make that a little bit simpler, it is the, how did I define it here? It is the coefficient in front when in standard form. So it is the coefficient out front when in standard form. So once you go and put your polynomial into standard form, the leading coefficient is simply going to be the number out front. So let's take a look at some examples here. These are the problems that we just did, so they're those, so hopefully you have them written down. And the leading coefficient, once you put them in standard form, the leading coefficient is simply the number out front. So the leading coefficient in this first one is -3. The leading coefficient in the next one is 3. and the leading coefficient in the last one is -3. In other words, it's just the number that comes out front. If you don't see a number out front, then the number is a 1. Now you might be thinking, well, the leading coefficient goes with the degree, like they're always on the same term. Yes, they are always on the same term. So once you identify which term should be in front, that's going to give you both the degree and the leading coefficient, because the leading coefficient is going to be the coefficient on that term. So what that enables you to do is, if you saw something like this is a polynomial function, and it is not in standard form, because your exponents, remember that's an exponent of 1, and this is technically an exponent of 0, okay? Just kind of tossing that out there. Is you look at your exponents and you see, okay, exponent 1, exponent 2, exponent 0, that is the highest exponent, so that's the degree. And the leading coefficient is going to be the number that goes with it, which in that case is a 4. And you don't actually need to rewrite it in standard form in order to identify the degree and the leading coefficient. Once you see what the highest exponent is, yep, the leading coefficient is the coefficient that goes with it. Just don't forget about the sign. So if that were a subtraction sign, like it would be a -4. So last little bit of practice, and then we'll call it a day with this lesson. Is simply to identify the degree and the leading coefficient of the following. You don't have to rewrite them in standard form unless you want to, but just notice what is the degree, what is the leading coefficient. So the first one is, what is the first one? F of x is equal to 3x squared minus 5x to the fourth plus 3. The second one is y equals -2x to the third plus 3x. And the third one is y equals 2x squared plus 1/2 x to the fifth minus 3x plus 1. And I'll pause the video here and give you a chance to just identify the degree and the leading coefficient. And here's the workout of this. So looking at the first one, remember degree is the highest exponent. We can see that the highest exponent is 4. So the degree is 4, and the leading coefficient is going to be whatever goes with that. So the leading coefficient is -5. In the next one down, the highest exponent is a 3. So that is degree 3. And the leading coefficient goes with that. So the leading coefficient is a -2. And in the last one, we can see that the highest exponent is a 5. So the degree is 5, and the leading coefficient is a positive 1/2. It should take you about that long to do it. This is a very simple concept, but loads and loads of students get this wrong on the test because they don't bother to practice it, learn it, and learn the words and learn what they're asked, to do there. So there is some homework on the worksheet that you are able to do based on this lesson. You can't do all of it because we haven't gotten to end behavior yet, but that'll be in the next lesson. Sorry this lesson was so long, and it's also really boring, and I can't do anything about that, but I am sorry about that. So we'll call that the first lesson.